All right. So on to chapter 9. Okay. Uh, getting. Okay. So the neural control of involuntary effectors. So now we're looking at the involuntary nervous system. So, or also known as the autonomic nervous system. Okay. Um, so the difference between autonomic and somatic. The somatic motor neurons have one axon going from the CNS all the way to the muscle. Okay, um, and that axon is very well modulated, so the speed is very quick. The autonomic nervous system has two sets of neurons. Okay, um, that makes it slower, and the modulation is usually less, so that also makes it slower. Okay, uh, so the first set has cell bodies in the brain or spinal cord and synapses to autonomic ganglion. The second one obviously starts at ganglion and ends at the muscle um, or gland. Okay. Um, okay. Okay. Uh, okay. So this, right? So there's two neurons. So the names of the two neurons, you have a ganglion in the middle. So pre-ganglionic neuron, post-ganglionic neuron. Okay. All right. Let's get reserve effects, blah, blah. Okay. So the autonomic nervous system acts on cardiac muscle and smooth muscle. Okay. Generally, these things contract on their own, and especially cardiac muscle, they have their own rhythm. What we do actually is alter that rhythm. They're like the muscles themselves are all auto-rhythmic. We're just speeding it up or slowing it down. Okay. 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 So neurotransmitters are different between the two. The somatic nervous system always releases acetylcholine, which is always stimulatory. Okay. The autonomic neurons release mainly acetylcholine um, at the ganglion, but at the effector, it either releases acetylcholine or it releases norepinephrine. Okay, and it might be excitatory and inhibitory, and we'll get into that in a little bit. Okay, so here's the differences. Okay, okay, so almost all of these things are important. Okay, so again, the somatic motor, the flat causes if you lose innervation, you get complete flaccid paralysis and atrophy. Like you lose the muscle basically. Um, Here in the autonomic motor system, you don't actually. In fact, sometimes they show something called denervation hypersensitivity, in which you become even more sensitive to the neurotransmitters. Okay. Okay. I'm sure if there's one thing you guys probably remember about this system, it is the sympathetic and the parasympathetic. The sympathetic is also known as your fight or flight response. Okay. Um, the funny way of saying it is responsible for the four F's. Okay. Fighting, uh, fight or flight, uh, fright, and the F word, which I won't say. Um, okay, that's the response to the sympathetic. Okay, blah, blah. Okay, so here, okay, let me actually show you a really simple picture. Actually, let me go back to this. Okay, the first chain of the sympathetic ganglion is very, very close to the spinal cord, and they all group together here, and that's called the sympathetic ganglion or sympathetic chain ganglion. Okay, and the reason why they're called a sympathetic chain really it's because they're literally form a chain. So you come off of this nerve and you can go up and down, and you can signal things up and down. So now you can have multiple signals come from one root. Okay, go to multiple ganglions and signal that ganglion. Okay, remember the flight response. The way you should think about a fight or flight response is running from a lion or a tiger. Because frankly, that is what the response is built for. It's not built to freak out on a first date. It is not built to freak out on an exam. It is built to freak out running from a tiger. Okay. Okay. The collateral ganglion, they come off the chain. So here they all are. Okay. Okay. The adrenal glands, okay, are very important to the sympathetic ganglion, or sorry, to the sympathetic nervous system, not the ganglion. So again, running from a tiger, I want to turn everything on all at once, and the best way to do that is just use the mass activation that's provided by your bloodstream. Okay, so embryonically, the adrenal medulla is a modified ganglion and innervated directly from preganglionic sympathetic neurons, meaning the adrenal glands are actually part of the nervous system. They're not really glands in the sense they come from ectoderm. They're actually part of the nervous system. Okay. Okay. The parasympathetic division is known as the rest and digest division. Okay, they're also called a craniosacral division because they come from either the cranial nerves or the sacral nerves. Okay, now this division is your rest and digest division. So when you're resting and digesting, you actually have time. Okay. So what happens is they have a very long preganglionic neuron. Okay, they have a very short postganglionic neuron. So I can tinker with each individual system however I want it because I have time. Like this is the sitting down with a Tuesday night with a cup of wine type of deal. Okay. All right. So again, the oculomotor, facial, glossopharyngeal, vagus nerves. Okay, the vagus nerve is especially important. Okay, in the whole parasympathetic nervous system, the vagus nerve takes about 70 to 80% of the entire innervation. Okay, so heart, lungs, esophagus, pancreas, liver, intestines, all of that is vagus nerve. Okay. Okay. Sacral nerves. Okay. Lower part of the intestine, the rectum, the urinary and reproductive organs. Okay. So here you can see that what the most important things are from the anatomy perspective. One, the location of where the nerves come out. So parasympathetic is literally called a parasympathetic because it's around the sympathetic. Okay, the sympathetic has a short preganglionic neuron, which results in the chain, sympathetic chain being right next to the spinal cord. Okay, and then the post is on the post is to the effector organ. That one's much longer. But again, if you want to think sympathetic, you want to think fight or flight. If I want to think fight or flight, I want to flip on all the switches and worry about details later. So all the switches are right here, and now you can flip on multiple switches and worry about all the rest later. Okay, the parasympathetic I have more time, so I can alter each switch. Okay. Okay. So I already covered this one, right? So okay. The cholinergic synaptic transmission. Acetylcholine is a neurotransmitter used by all preganglionic neurons. However, okay, it's not always a transmitter in the postganglionic neurons, especially for sympathetic. Sympathetic postganglionic neurons, some of them release ACH, others release norepinephrine. Okay. All right. So epinephrine. Okay. So okay. So the here, okay, this is the parasympathetic is in blue, so acetylcholine at both places. Okay. And the sympathetic is acetylcholine to epinephrine or norepinephrine. Okay. All right. This one. Okay. Okay. So I think the hardest thing for you guys to understand is the difference between alpha and beta adrenergic receptors. Okay. Okay. So there are two subtypes: alpha 1, alpha 2. Two beta types: beta 1, beta 2. Okay. Alpha receptors are more sensitive to norepinephrine. Beta receptors are more sensitive to epinephrine. Okay. All right. So if you think of your response, your fight or flight response, okay, let's go through alpha 1 first. Okay. Alpha 1 is going to contract the radial fibers of the iris, which in turn dilates the pupils, so you can see better. Okay. The arterioles will constrict due to smooth muscle constriction. Okay. You don't want your and I will come down here, stomach intestines as well. Okay. You do not want blood going to your skin because you don't need blood going to your skin, which is why you turn pale when you're scared. Okay. You don't want blood going to your stomach intestines because you're not digesting anything when you're scared. Okay. Now, the beta 1. Okay. So your skeletal muscles, the arterioles will constrict due to sympathetic nerve activity. That I will address in a little bit. That seems backwards, as does the liver 1. That seems backwards, but I'm going to address that in a little bit. Okay. Heart. Okay. Beta 1 causes an increase in heart rate. Okay. So my heart pumps harder. Okay. So if beta 1 increases heart rate, what do you think beta blockers do? They decrease heart rate. Okay. Okay. Beta 2, okay, causes the bronchioles to dilate. So beta 2 is used to open up airways. Okay. Now beta 2 is also found in skeletal muscle and in the liver. Okay. So here's the cool part about this. Okay. You're running for your life. Yeah. You're using some muscles and you're not using others. Well, you only want your blood going to the muscles that you're freaking using, right? You're not, if you're running away, for example, you don't care that the muscles of your face get blood. You care the muscles in your arms and legs, especially your legs, get blood. So what do? Well, when you exercise, when you're actively moving those muscles, okay, the alpha 1 receptors get blocked. So they're no longer responding to alpha 1. So they're responding to only beta 2. The beta 2 causes the blood, the arteries to dilate. So now, whichever muscle you're moving gets huge amounts of blood. The muscles that you're not moving, they respond to alpha 1 more than beta 2. So they constrict. Okay, so now you only have blood going to the muscles that you actually need to use. Okay, and that's the same for the liver. The beta 2 overrides the alpha 1. When you start doing this, your alpha 1 gets overridden, beta 2 takes over, and you get the secretion of glucose. Okay, more blood sugar. Okay. Blah, 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 blah. Okay. So, okay. So, some drugs lower blood pressure, act on these alpha 2 receptors. Okay. So let's go through the drugs. Okay. Okay. Alpha blockers. Okay. So short-term control hypertension. This one raises blood pressure, improve male sexual function. So I'm sure you guys know what that means. The beta 1 blockers is the treatment of hypertension. So beta 1 causes increased heart rate. So beta blockers decrease heart rate. Okay. Alpha 1 causes vasoconstriction, so increased blood pressure. Alpha 1 blockers, okay, or alpha blockers cause vasal relaxation, therefore lower blood pressure. Okay. Okay. All right. Okay. I think I explained these last time, okay, in the last chapter, but they pretty much work. Yeah, we explained this last time, okay? So the nicotinic receptors, they're all stimulatory because this opens up the channel, and that's all it does. So open up a channel automatically causes depolarization and excitation. The muscarinic, it can do either depending on what's downstream of it. So there's more options there, okay? Okay. Okay. This you can read by yourself, and there's not much to it. Okay. Okay. So like I said before, most of the time these systems are antagonists, like heart rate. Sympathetic increases, parasympathetic decreases. Digestive system, sympathetic decreases, parasympathetic increases, etc., etc. Just understand that the sympathetic nervous system is stronger than the parasympathetic. Okay. The parasympathetic is mostly on all the time, but again, if you need to run, you need to run. And therefore, the sympathetic overrides the parasympathetic. The response is stronger and it lasts longer. So it is better, like if you receive both signals, it's better for you to run from a non-existent tiger than to not run from an actual tiger. Okay? Okay. Sometimes they complement each other. Okay. The cooperative effects are pretty when both divisions produces different effects that work together to promote single action. The parasympathetic causes vasodilation and erection. The sympathetic causes ejaculation. The way I remember this, parasympathetic, it starts with P, therefore causes pointing. The sympathetic, it starts with S and therefore causes shooting. Okay. All right. All that. Okay. The following organs are innervated by sympathetic division only: the adrenal medulla, obviously, because that's a sympathetic ganglion. The erector pili, muscles in the skin. So when you get scared, you get goosebumps. Okay. Sweat glands in the skin, blood vessels. Okay. Okay. Okay, so all of these are regulated medulla. Okay, and the higher brain regions regulated medulla, especially the hypothalamus. The hypothalamus is the most major regulatory of the ANS. In fact, the hypothalamus per unit mass controls a whole crap load of stuff. Okay. All right. Um, okay. Yeah, you can read about aging. Okay. There are different types of receptors here that do different things. Okay. Okay. Um, so let's see. Chemoreceptors in the aorta is pretty important. Okay. So stimulated by rise in CO2 and falling O2 produces increased rate of breathing. So if there's CO2 increasing or O2 decreasing, especially CO2 increasing, it makes you breathe harder. Okay. And causes vasoconstriction. Okay. Okay. All right. Hopefully you understand that chapter. If not, feel free to message me.